Hey there, I'm John Burney, and welcome to Machine Health 101. Today we're talking about one of the most foundational tools you'll use in condition monitoring, trend charts. So what are trend charts? In simple terms, they track how certain parameters like vibration, temperature, or speed change over time. This is incredibly valuable because machines rarely fail suddenly and all at once. In most cases, there's a gradual change, a small increase in vibration, a deviation in temperature, or some subtle shift in performance. A trend chart lets you see these changes before they become critical. There are a few key reasons why trend charts are essential in vibration analysis. Firstly, trend charts are used for early fault detection. By watching how vibration levels change over time, you can catch issues like bearing wear, imbalance, and misalignment early before they lead to breakdowns. Secondly, trend charts are used for maintenance validation. After you've done a repair, trend charts help you confirm that it actually fixed the issue. You'll usually see the vibration levels drop and remain stable. Lastly, trend charts enable us with better decision making. With long-term data at your fingertips, you're not guessing or assuming when it's time to take action. You can make informed decisions about when to perform maintenance and when to leave things alone. Now, what kinds of data can be trended? There are two main types of vibration features that are commonly tracked in trend charts: broadband and narrowband. Broadband trends give you the big picture. This includes parameters like RMS velocity, RMS acceleration, peak, and crest factor. RMS, or root mean squared, is essentially the average energy level in the vibration signature. RMS velocity is particularly useful for identifying mechanical faults like imbalance, misalignment, and looseness. It's a great overall indicator of how much stress the machine is under. RMS acceleration, on the other hand, is a great indicator for higher frequency issues like early stage bearing wear. Then there's peak, which measures the highest instantaneous value of vibration. It's useful for identifying sudden impacts or spikes like a broken gear tooth. Crest factor is the ratio of peak to RMS. When this number starts to rise, it usually indicates that something new and sharp is entering the vibration signal. It could be an early warning sign of developing issues like bearing damage. By tracking these broadband metrics over time, you get a clear sense as to whether your machine is behaving normally, gradually deteriorating, or experiencing some sudden issues. Narrowband trends, on the other hand, zoom in on specific frequencies within the vibration spectrum, like 1x, 2x, and other harmonics. These trends help identify and track faults that are tied to specific machine components. 1x refers to the speed at which the shaft is rotating. For example, if you're monitoring a motor that rotates at 1800 RPM, 1x would be 30 Hz. Elevated vibration at the 1x frequency usually points to issues like unbalance or misalignment. 2x and higher harmonics can reveal different fault types. For instance, 2x vibration is often associated with misalignment, especially angular misalignment, while 3x or 4x may indicate gear mesh issues or looseness. Trending narrowband frequencies can help you spot subtle changes and determine if a specific fault is getting worse, even if the overall broadband values haven't changed much. Narrowband trends are particularly powerful when paired with frequency markers, fault frequencies from bearing libraries, and speed tracking. Together, they help pinpoint exactly what's going wrong and where to look when diagnosing more complex machine issues. You can also trend non-vibration data like speed, temperature, or process variables to add more context. Some platforms, like Petasense Aero, let you overlay multiple parameters on the same chart, making it easier to spot patterns, like how vibration changes with temperature or running speed. One tip when using trend charts is to always compare data under similar operating conditions, especially speed and load. Otherwise, you might confuse normal operating changes with potential faults. Take this example, where we have a triaxial vibration trend from a cooling tower fan. The vibration levels appear to fluctuate pretty dramatically across all three axes. At first glance, it might seem like something's wrong. But when we overlay the machine's running speed, it becomes clear that the changes in vibration are actually caused by changes in speed, not a fault with the machine itself. Some systems allow you to filter trend data by running speed, which makes it easier to spot actual issues versus normal operating behavior. Trend charts might seem simple, but they're powerful. When used consistently, they give you a clear window into your machine's health and can help prevent costly surprises. Thanks for watching, and if you found this helpful, feel free to follow along for more bite-sized insights on condition monitoring, predictive maintenance, and best practices in industrial reliability.